Notes 5.1, solving systems graphically. So I'm going to give a little shout out because we're doing a live recording to my Block 1 Syracuse class. They're in the room while I'm doing this. So question number 1, circle all quartered pairs x, y that are solutions to the equation 4x minus y equals 10. So I've got that equation and I've got a list of points down below here. And I've got to circle all the ones that are solutions to that equation. So in order to determine if something's a solution to an equation, we've got to check it. We've got to plug those values into the equation and see when we get true. So let's start off with 3, 2. Okay? We have an x and we have a y. So we're going to take that 3 and that 2 and plug it into our equation. So 4 times 3 minus 2, does it equal 10? I'm going to put a little question mark over that because I don't know if that's true. So then I would start 12 minus 2 equals 10, and yes, 10 equals 10. That's true. So 3, 2 is a solution to that equation. I'm going to circle it. Now, what about 2, 3? We're going to do the same thing. We're going to check to see if 2, 3 is a solution to that equation. So I'm going to plug that point in, do the same thing. I'm going to say 4 times 2 minus 3, does it equal, with a little question mark, 10? So does 8 minus 3 equal 10? Hopefully you're seeing, okay, does 5 equal 10? No, that's false. So 2, 3 is not a solution. So we're not going to circle that. Now I'm going to go to the next solution, possible solution, that -1, -14. And I'm going to have to write that down here. So I've got a little space. Do the same thing. 4 times -1 minus, now I've got to put that -14 in parentheses because it's minus a -14. And does that equal 10? Okay, I'm testing these points to see if they're solutions. So 4 times -1 is -4. Negative, negative. Okay, that's going to become that super positive. So when I continue on, I have -4 plus 14. Does that equal 10? And yes, so that equals 10, so that's true. So that's a solution. Well, let's continue and let's try 0, -10. So 4 times 0 minus a -10, does it equal 10? And if with 0 plus 10, wow, that equals 10. So that's true. So 0, -10 is a solution. Let's try one more. Let's try that 3, I'm going to write it down here, 3, 4. So 4 times 3 minus 4, does that equal 10? 12 minus 4, again, I put that question mark over it. And does 8 equal 10? No, it doesn't. That's false. Okay, so that's not a solution. So right here we see 3 solutions to 4x minus y equals 10. It says find another solution to 4x minus y equals 10. So, I don't know, let's try something. So if we try, I don't know, I'm going to try 5, 10. Let's see. Because 4 times some value of x minus some value of y has got to equal 10. So let's see, 4 times 5 minus 10, does that equal 10? 20 minus 10 equals 10. Holy smokes, found another solution. That's true. Okay, so that's another one that works. So let's think about what 4x minus y equals 10 is. What is that? We just dealt with it in our last unit. So I'm going to rewrite it down here, and then we're going to answer question 3. If I were to isolate y, Okay, last unit, we isolated y. We got y by itself, so we could get it into y equals mx plus b. And I would have to divide by a -1. And I end up with y equals positive 4x minus 10. And then if I went to a graph and I graphed that, 4x minus 10, I'd know that my slope is 4 over 1. That's my rise over my run. And that my y-intercept is -10. If I went to graph that, what would I get? Hopefully you'd say you'd get a line. Okay, you'd get a line. And obviously I'm just drawing a little sketch of this over here. I'd have a line, okay, that would be something like that. Positive slope, okay, y-intercept to -10. Obviously that's not drawn to scale at all. Okay. And what are all these lines or points that make up this line? They're all solutions to the equation 4x minus y equals 10. How many points did I just put in red on that line? You can't even count them. So how many solutions are there to 4x minus y equals 10? Again, how many points did I just put? And I could put some more on there. How many solutions are there to 4x minus y equals 10? Hopefully you're going to say there's too many to count, because there are an infinite amount of solutions to 4x minus y equals 10. Let's see if I can shrink this up a little bit. I can put our answer in there. So how many solutions are there to this? There are an infinite amount of solutions to that equation. Infinite amount of solutions. Okay? So now we're going to talk about a system of equations. A system of equations. So notice that that's plural there, equations. So we're going to have, okay, more than one equation with more than one variable. So more than one equation to solve with more than one variable. So when I look at question number 4, I've got, this is called a system because I have two equations and I have two variables. So I have two equations and I have two variables. I have x's and y's in both of them. That's what makes it a system. But I have to solve this system. Well, you don't know how to solve an equation that has two variables in it, x's and y's. Right now you don't know how to. But really, we know a method to solve that system of equations for x and y. You already know the process. It's called graphing. Okay? We know how to graph lines. So let's graph this first line. So I know that there's a 1 in front there. So I know my slope is 1 over 1, and my y-intercept is -4. So let's go down and graph that line. So my y-intercept, where I begin, is on the y-axis at -4. And then I do my rise over my run. So I go up 1 and right 1 from my beginning point. Up 1, right 1. Keep doing that same pattern till I get a nice line. And I absolutely grab my straight edge and draw in a very accurate line. So nothing new right now, correct? And I put my arrows and I put my label. So nothing new. Now let's graph the second line to this system, the second equation. So I know my slope is -2 over 1 and my y-intercept is 5. So where do I begin on the y-axis? I begin at 5, and my rise over my run tells me to go down 2 and right 1. Down 2, right 1. Down 2, right 1. Oh, bumped into that other line. Huh. Down 2, right 1. Down 2, right 1. That looks kind of good. And now, again, grab your straight edge. And make sure you have a nice, accurate line. Put your arrows and write your equation. Again, nothing new, right? We know how to graph lines. So, what is the solution? What's the x and the y? If I were to solve for this, that makes this true. Do you think those two lines bumped into each other just by chance, or was that on purpose? Hopefully you're saying, that's on purpose, Mrs. Vincent. Right there. What is that point that they bumped into each other, that they're equal to each other? So that point right there is 1, 2, 3, -1. And I'm going to label that point 3, -1, where they bumped into each other. That was not a chance. That was not by chance, but that just happened. Okay. So let's check if 3, -1 is a solution. Just like we did up in the beginning. Let's check where they bumped into each other. Let's see if it's true for that first equation. So my first equation was y equals x minus 4. And then I'm going to check my second equation and see if it's true for that point where they bumped into each other. So let's see, does -1 equal 3 minus 4? Holy smokes, I should put a question mark there. Got a little excited. -1 equals -1, that's true. So far so good. 3 -1 is a solution of the first equation. Let's see, is it a solution for the second equation? Do the same thing. Put the -1 in for the y, -2 times the x, which is 3, plus 5. Put a question mark. Let's see if it's true. -1 equals -6 plus 5. Holy cow. We got a second true. So, is 3 -1 the solution to this system? Did we just solve for x and y? We certainly did. Okay. So our solution is 3 -1. Okay. Let's do one more. Whoa, number 5 looks crazy, but we still know how to isolate, okay? We know how to isolate y, because in order to graph, we've got to isolate y. So I'm going to subtract 18 from both sides. So I have 6x minus 18, and then to continue to isolate y, I've got to divide everything by 3. So I'm going to get y is equal to 2x minus 6. So my slope is 2 over 1, and my y-intercept is -6. So let's go ahead and, where do we begin? Okay. We begin at the y-intercept, which is -6. So I'm going to go down to -6 for my beginning point, and then I'm going to do my rise over my run, which is up to right 1. Do it a few times. Okay, again, nothing new. You know how to graph lines. Grab your straight edge. Draw your nice accurate line. I'm going to straighten mine out a little bit. Make sure it goes through my point. Put my arrows and label it with the original equation. And now I'm going to go and take my second equation, and I've got to solve for y again. I've got to isolate y, so I'm going to subtract x. And I get -y equals -x plus 4. And I'm going to divide by -1 everything. So y is equal to 1x minus 4. So my slope is 1 over 1. And my y-intercept, or my beginning point, my starting point, is -4. So I'm going to go to where I begin on the y-axis at -4. And then I'm going to do my rise over my run. Up one, right one. Up one, right one. Holy cow, it just bumped into that line we had. Up one, right one. Up one, right one. Keep going so I get a nice neat line. Grab that straight edge. Draw in that line. Make sure it's really accurate. Put your arrows and label it with the original. Now, again, they bumped into each other. That wasn't just by chance. Let's label that point. What is that point where they bumped into each other? It was right 2, down 2. So it's 2, -2. Let's see if that is in fact my solution. So let's check it. We got to check it into the original 2 equations. So I'm going to check 2, -2. And my first equation, 3y plus 18 equals 6x. And my second equation, x minus y equals 4. Let's check that first equation and see if we get true. So 3 times the y value. The y is -2 plus 18. Does it equal 6 times the x, which is 2? So I get -6 plus 18. Up. Here we go. Does it equal 12? And it sure does. 12 equals 12, so that's true. So far, our solution is good for the first equation, but it's got to be good for the second equation too. I'm just going to write this down here so I got a little bit more space. So plug my x value in, 2 minus my y, which is a -2. Does that equal 4? Put a question mark. Let's see. Oh, I forgot my question mark in that second one. Or the first one I did. There we go. So 2, holy cow, plus 2, does it equal 4? 4 equals 4. That's true. Both are true. So my solution to my equation, my system of equations, I just solved for x and y, is 2, -2. So I'm going to go back up here. And I'm going to write 2, -2 is the solution. Okay? So, I believe, let's see if I go to the next page. Oh, we're good. Okay. We're going to practice. Okay? So nothing new today, really. You know how to graph. You know how to isolate y. The only new piece is finding where those 2 lines bump into each other because that's our solution. Okay? Nice job, guys.